So today's webinar is part of a webinar series on mobile app quality. Today we're going to be talking about how to accelerate your releases. We have a number of clients that are talking about trying to move from multiple week releases to daily releases if they can. And there are a lot of roadblocks to doing that and limitations. And so this webinar is talking about how to think about doing this, especially in the context of regulated industries. I love starting talks with this slide because it helps us focus on why we're doing what we're doing. Your CEO does not care how many tests are passing. They don't care probably even if you are doing continuous delivery or what your process is. They're interested in making sure that the money is coming in. They've got users that are whatever the revenue stream is executing, that things are going well. And there are a lot of factors that go into this, especially when we're talking about regulated industries. So what you need to ask yourself as you're figuring out what's important, who are your users? Are you a business to business, a business to consumer? That's going to affect how you're thinking about your overall testing strategy. How do your users generate revenue for you? Is it with an activity? Are they paying a subscription? Is it just viewing ads? Understanding how much does it cost to get new users? Like what is the cost if you lose users as a result of things of bad quality in the product you've released? And finally, thinking through like what workflows are critical to revenue and which don't matter. One of my colleagues was very proud that he spent some time on one part of his app, like really, they spent a week like really making sure it was thoroughly tested and everything was working correctly. And he showed it to his boss, and his boss is like, no one visits those pages and it brings in zero revenue. Why did you waste a week of everyone's time? And understanding which parts of the flows are most important and which things need to be prioritized is crucial to having a successful testing strategy. So these are the questions that you ask about what does the revenue look like? Oftentimes, the component to this that matters is making sure that if there's bugs, you fix them. If there's features you don't have, you add them. If there's things that need to be pushed into production, it can happen quickly. And so that's all about throughput and figuring out how long it takes to get value out of your testing strategy. And this is the process that we've seen in the industry. We've gone from a very waterfall approach, and we're trying to move to the continuous testing phase. Honestly, most Sauce Labs customers are still in what I consider a basic automation phase, where the deploy frequency is weekly to quarterly. There is separate QA and dev teams still. You're using CI, but not really integrating everything in one place. Tests are daily instead of per event. And I think that's really the big key difference between what I consider basic and advanced automation. Are you running your tests at a set time interval, or are you trying to evaluate code updates that have specifically been made? This pull request has been merged in. Let's test this new chunk of code. And if there are failures, we can associate them with those changes that were made. But that requires a certain level of maturity in making sure that your tests are good and how many tests are good. This is kind of a scary slide. This is enterprise organizations with the range of pass rate. So let me describe what this means. Approximately 20% of our users, enterprise users, have a pass rate of 90 to 100%. I would consider that a good signal. You can get value from that right away. You can see what's passing, what's not. If you're testing code that was just released, just added, you can get a good feel for whether that code is good or bad. This segment where your pass rate is between 75% and 90%, it's kind of a work in progress. You can probably tweak things to get it to a good part. Like maybe some changes were made and you're catching up. Maybe you inherited something from someone else that you've got to go through and address. There are a number of ways, but it's reasonable that you can work with a 75 to 90% pass rate. The problem is look at just how many people, approximately 2/3 of organizations, are reporting their pass rate as being less than 75%. And once you get into that range, the value you're getting from your tests is minimal. You're putting a lot more time and energy into dealing with tests without getting much real value as a result. So they're the same number of bugs in the same position in these two images, but one is hidden with all of the false failures that you're getting, and the other, the tests, the failures pop out. These are the problems because everything else is passing. It's really easy to see. So this is generic signal to noise kind of idea. If you have too many failures, you're not going to be able to see the problems when they show up. And if you're not seeing the problems, you're not getting any value. So what are the implications of the industry overall having a low average pass rate, and what does it mean for regulated industries? Either you spend the time to verify all of the failures, which results in a lower throughput, or you release faster and you just don't verify everything. It's probably good enough. And maybe you have smoke tests that like these are the important ones that have to pass, and all of these others that are failing, we're just going to ignore and pretend we know what they're doing. Neither of those are good strategies. So, and this is one of those things where, especially in regulated industries, you're pretty much stuck doing the first one. You can't get away with things that like a social media company that can move fast and break things, any kind of tech, being able to run through and just put new stuff out there and not worry about it and deal with it when it's in production. For regulated industries, the goal is we need to move from the first one to the third one, where we spend the time where we can improve the verification process so that it doesn't reduce throughput. So let's talk about risk profile requirements, because I'm talking about different industries and we're specifically thinking about regulated industries. Now there's a lot on this slide here. I was trying to figure out a way to do a 5-dimensional graphic that showed how all of this, and I'm like, it doesn't really matter the details. This is big picture, not super accurate, but just trying to think through the different ways that you can evaluate the quality of your site and your users and what you need to do to have a good test strategy. So different industries, the stickiness is how hard is it for users to leave you? Like you don't want to change your bank just because you noticed a typo on a website. You probably can't change your healthcare app because that's the one your company uses. It's the loyalty is compulsory. And maybe in a financial, maybe your bank, you're not super loyal to it, but it's the one you have, and so you're not going to move off of it. And what we see in these highly regulated companies, the importance of the user experience is much lower than in a lot of other industries, a lot of these other verticals. And so that changes how you think about what tests you need to run in order to get the throughput and focus on the things that are important for your CEO, the shareholders, the board of directors, the people that are pushing your company forward. And there's a lot of assumptions. Look at this as kind of very hand wavy here, but you can see at the bottom, like social media, people love whichever their Blue Sky or their Twitter, and they're going to stick with it, regardless of typos or feature issues. But like if you go to transfer money in your bank and you can't transfer money at a certain time because there's a problem on the website, that's a big deal. Like that's the kind of thing where, okay, this has gotten to the level where I need to move to another service, because if I can't do the core thing that I need to do when I need to do it, that's crucial. So things like that is what you need to think about specifically for the industry you're in, and the way the risks weigh out for what you need to deliver in your app. The other thing for regulated industries to keep in mind is the tests themselves might not even be the most important thing in your test strategy. How you're managing your test data, how you're setting up the framework to manage the test data, that might be more important than the assertions and actions you're taking in the tests themselves. Same thing with the orchestration and the storage of the data. This is all stuff that, for compliance reasons, it's crucial that you have this thought through and that the process is rock solid and you know exactly what's going on and it's auditable. And that's one of the reasons I'm pulling this straight from our website. SOC 2 Type 2 compliant, ISO 27001 certified, and we're very open about what our security practices are and what we do to make sure that any sensitive data that you might send to us is secure. And beyond that, regulatory is also more focused on things like regulations, the GDPR, the Americans with Disability Act. The websites that we are using are compliant with all of the requirements that are now legally out there. And so Sauce Labs does have desktop accessibility testing with a DQ integration. We've got a new results dashboard here that lays out exactly what's going on and lets you dial in to get more useful information. We also support the mobile accessibility through DQ. We partner with DQ for these things. This one, you do get useful information here from all of these things, but it does require a DQ license to get these things. So we're working with them on how we can improve this experience, but it is available to run your tests with DQ on our service and get this information directly tied into the Sauce Labs app. The other component here is visual testing, something to keep in mind. We have a visual product that is significantly improved if you've tried our visual testing in the past. We have a really great product. We did an overhaul. Things are looking really good here. This is to keep in mind that oftentimes the functional tests themselves aren't good enough for UI validation. It does make sense to have an auditable path of here are the assets, here's the changes we made, here's what it actually looked like. Some of this, I think, is more important for people that are trying to ensure the display is working, make sure the content is there. This actually might be less important for regulated industries where a typo doesn't matter as much. And as long as you can fill out the form, it doesn't really matter if things aren't displayed exactly the way they should from point to point. It's more important that you be able to fix problems than you prevent them from happening. And I'll talk about that here in a second. So we talked about we need to improve our failure rates. The first thing that everyone talks about is this idea of shifting left, shifting right. So this is all part of the software development lifecycle. And the idea is that you're going to evaluate the value of things. You're going to see what quality has been maintained at each stage that you're doing something. So you are planning something and writing the code, you need to run unit tests. You're building the app, you need to run your integration, service layer, contract, API tests. Then you're going to deploy it somewhere, and this is where you're going to run your UI tests, your black box API tests. And then once you release that code and operate it, then you're going to be doing, and after the release, you can do additional tests in production, depending. And again, regulated industries, you have to be more careful. I think with your production testing, there's some things you just can't test in production that other people could get away with because it's real data. And there's more concern around testing with the real data. But monitoring is something that everyone's going to be doing. Monitoring is making sure that if there's something that's happening real time out there that users are actively experiencing, that you can recognize that when it happens. The idea with the reason I show this is it really helps display the shift left, shift right idea. The part on the left is if you're focusing on doing more over there with your unit tests and your integration tests, service layer, contract tests, that's shifting left. And if you're doing more with testing in production or testing after deployment or doing monitoring, I guess this is the traditional deploy and test it. Anything that you would do on the right side would be shifting right. So we'll talk about what these look like and how they work at Sauce Labs. One way to think about shifting left is the traditional test pyramid. You have black box testing, gray box testing, white box testing to represent the UI tests, the integration tests, the unit tests. The idea that people have been pitching for 20 years now is you want to have more unit tests because they're faster, cheaper, more reliable, fewer flaky issues. And then you want to have integration tests that test the different components. And then you want to have fewer UI tests. This is the mobile, the Appium, the Selenium, the full DOM, the database evaluation of the functionality of the application. And The reason you have fewer of these is because they are slower, more expensive, more likely to be flaky. There's just a lot more moving parts. And so you only want to test the things that you can only test in the UI with the UI. One of the problems with the pyramid in theory is that in practice, if you have a split QA and dev team, which is still pretty common in a lot of regulated industries, you end up having the devs focusing on unit tests because code coverage is the metric they're being graded against, and the testers, the QA team, being focused on this DOM to database test. It only counts as a test if you're going through the browser or the mobile phone to execute the test. And the problem is everyone's kind of leaving out this integration testing in the middle, which I think is the sweet spot. There's also a like the testing trophy is out there as another idea, and I really agree with the principles there that really we want to focus more on what's going on in that middle layer, and we want more of this middle layer. Even in unit tests and DOM to database tests, there are issues with unit tests that can give us a false sense of security, where service layer and API tests. And I split this up because a lot of people that are traditionally QA testers don't even think about the fact that you can still keep your black box testing and only focus specifically on the API. You can pull the browser out of the testing experience, just hit the endpoints with an HTTP client or REST client, and get much more reliable information. So you use this for testing combinations and permutations of data that you're entering into forms. Have the full stack DOM to database test that checks, does entering these values in these fields in this form, does this form work correctly? It does. And now all of the ways that you're setting state in the back end with that form and what that looks like on the front end, or what state gets changed and what toggles happen in the back end, you can do all of that with straight API tests without needing anything in DOM to database. So specifically mobile device testing. We said that browser testing is hard, but there's a lot of things that browser tests don't have to deal with that mobile tests do. Mobile tests don't have any standards. There's no HTML specification for web apps. You have Apple and Google, each with different ways that they're doing things. Apple is notoriously circumspect about describing how they're doing some things that make it hard to reverse engineer to do things for Appium and things like that. Different hardware, different processors, different screen sizes. Your connectivity options are different. You have different operating systems, different vendor skins. This is all different. So the idea that we have here, that's a smart idea, is if you're going to all of the trouble of doing a full stack mobile application test, it makes sense to actually test against what customers actually use. If you're using an emulator or simulator, or you're doing some kind of emulation, you're not actually testing what users are actually doing. You're spending all of the time to write the test, but not actually testing on what users are using. The problem with that is this is what your users are using. There's just way too many things that you can't test everything that your users are going to use. So it's not a matter of whether you're going to have trade-offs, whether or not you're going to balance how you're testing mobile. It's a matter of what your balance looks like and what your choices are to get the most out of your testing strategy. So this is where the mobile test pyramid comes in. And this is a few people in the Appium ecosystem have talked about this pyramid quite a bit. Note that this pyramid kind of lives in the UI portion of the traditional test pyramid. So this is all part of how you do different ways of doing DOM to database tests or full stack tests. And this describes it pretty well. There are three ways essentially to do mobile testing on Sauce Labs. In our real device cloud, we have public cloud and a private cloud, and you can test either Chrome or Safari and iOS native apps or Android native apps in either public or private. All of those are available. Emulators and simulators, these run in our virtual device cloud, the same concurrency you use for your browser tests. You can spin up a simulator or an emulator, emulators for Android, simulators for iOS, and then the respective browsers on those devices. The other thing that a lot of people don't realize you can do is if you are only running Chrome on So a mobile web test. So you don't have a native app, it's a mobile web test, and you're focused on Chrome. You can actually do that in the browser. So let's talk a little bit about how we shift left within these options here. The first thing that I want to talk about is we have a new simulator offering. And this is really exciting because I have often told people that the right way to do tests is to have a bunch of atomic, autonomous short tests. You do a bunch of very specific things and you do them all in parallel. And then I tell people to use emulators and simulators to scale. Like run your real device tests, but then if you need to really see a lot of throughput, use simulators. And that's the right advice in theory, but it's been frustrating when you realize that, hey, it takes 2.5 minutes to boot up this simulator, and then it takes a long time to actually run the test. And that's very frustrating because it ends up being difficult to actually run at scale when you're writing your tests, what I consider the right way to write the tests. So we now have an offering that allows you to boot up in 30 seconds and it runs 40% faster. It's like you can now do the best practices of writing your tests actually at scale and get real value out of that. And to me, that's the much more interesting piece of what the value you're getting from doing that, than the fact that that's what you need for the latest versions, but also you get the latest versions. But really figuring out your process and getting the most out of your process makes a big difference. And the reason is it's not just execution speed, it's easier to maintain atomic autonomous short tests. So if you're doing things the right way, this facilitates that and makes the maintenance easier. I'll talk about that more in a second. So this is what the mobile emulation looks like. If you right click on your Chrome browser and click inspect, there's this little button at the top. And when you click on that, it pulls up this drop down where you pick which device you want to use. And then you can see that the site in the background now resizes to those dimensions that are preset in Chrome. And then it sets the user agent to what you would expect from those devices so that you get, they call it device mode is what Google calls it. And it gives you a decent approximation of the dynamic sizing that happens in a mobile browser for mobile. So you're not tapping and swiping and things like that. You're essentially you can just use Selenium on your mobile browser to see that, yes, with the resizing, nothing got lost in the mix. And it's significantly faster than running an emulator in the virtual device cloud. So this is something that not a lot of people know about. You essentially set this in your Chrome options in Selenium. You specify in your capabilities, you list out the Goog mobile emulation values, and you can set you can set dimensions or you can set the specific values for these devices. So what does this mean for maximizing your usage on Sauce Labs? Figure out what the right balance is for your context. It's going to be a little different for different people and for different testing needs, but you still need to test on real devices because that's what the customers are actually using. And emulators and simulators are not perfect at reproducing exactly what customers are seeing. That's kind of the default generic, did I do something bad in the code versus when all is said and done, can a user do the things they need to do? So I recommend regularly testing, at least daily, on real devices, on the real devices that your customers are actually using. Look up those stats, see what they're using. I worked at a company that we found out that more people were using iPads to access our Froofy e-commerce site than web browsers. And so I'm like, okay, yes, we absolutely have to test with the iPad settings instead of just browsers. So I recommend you absolutely have to use real devices, but then for scale, to check the code, to add the additional maturity of, did I break something in this code? We recommend using emulators and simulators and recognize that experience has gotten much better for simulators recently. Things were never as bad with emulators, but really, it really shines now on the simulator. So per commit or pull request, code-based, run those tests at scale, get immediate feedback, shorten the feedback loop to get information to the developers. You can skip devices entirely if you are only testing mobile Chrome. So if you're testing right now on a real device, Android, with a mobile browser that's just Chrome, you're getting the most, you're definitely getting the most value out of that, but it's probably cheaper and easier and faster to do it with emulation in the browser itself, if that's your focus. So keep in mind, again, it's all a balance and context matters. But keep in mind that these are ways that you can split out, figure out what throughput you're getting from the way that you're testing things, not just what you're testing. So what does shift right mean? Like big picture, shift right is figuring out that, hey, maybe it is cheaper that instead of having an army of testers that are going to prevent any and all bugs from getting into production, what if instead of that, we make it easy enough and fast enough to quickly fix problems that we see in the real world and address them? And so the total impact to our users might be less if we fix problems that we see, if we can do that fast enough, than trying to prevent bugs, ultimately failing because bugs are always going to get out there. And then if we're too slow at releasing fixes, the user is going to have to deal with that bug for a week until the next release or whatever that looks like. Whereas if you can fix something that users are dealing with in an hour, in 30 minutes, maybe it's better to actually have in production. So this is the idea. Is this something that's workable for regulated industries? Not as much. Like you really don't want something that you have compliance limitations getting out there and then just dealing with it in production. You do, and maybe there's probably a balance here. Maybe some of the tests that you're running, you can make those into some kind of a shift right approach, but you're still going to need to make sure that the important things that could cause violations that absolutely have to be rock solid in order for your users to get the value from your application is what you need to think about. I remember e-commerce company I worked for is just like as long as we can ship product and take money, that's all that matters. It's just like, okay, so lots of things can go wrong and we can still ship product and take money before there was a real issue. So again, very context dependent. What this means in Sauce Labs, we have an error reporting feature that you attach this to your application code itself, and it will tell you when in the real world there's been an exception or an error in your application code itself. So this is not Selenium tests that you've run. This is while you're running your Selenium tests, the application itself had some null pointer errors in the back end. Maybe it doesn't affect what the user's seeing, maybe it does. But if it's a null pointer error or some other weird thing going on in the background, you want to know about it and make sure, because it's an unintended thing that you want to fix. Here, and we talk about this in a shift right context, but I think that's also doing a disservice to this feature. You can do this after you deploy them before you release. Run your tests, see if you're getting errors in the back end. You can do this as part of beta releases where you use our mobile app distribution setup and you have different versions with different release goals, and you allow beta testers to access through that distribution feature certain versions before it's released widely to the public. And then as they're using it and exercising it in the real world, you can see these errors. So this is one way that you can do shift right and get real world monitoring on what users are actually doing in the real world and causing problems. It's part of the solution, but also it's worth noting that it can be applied at multiple places in the software development lifecycle to provide value. What we talked about before, what is it that we're doing to improve the verification process? Because getting better at doing the verification is what allows us to maintain throughput while still making sure that our tests are passing, that our feet, well, not just our tests are passing, that we have found the problems in the code, regardless of whether the tests are passing or not, before we release the next version. But the idea is traditional QA, you're going to shift left, but you still end up with a lot of effort and resources. And then you shift right to catch issues in production, and you're seeing a lot of effort and resources still, just in a different direction. And what we want is we want a continuous quality where we're doing things across this whole life cycle. And we want to reduce the effort and resources because we're testing the right things at the right place, the right way. The problem with doing this is when you add all of these things together, it takes too long. And what do I mean by that? So I've talked for years about the cost of automation, kind of separating it out into creation costs, execution costs, and maintenance costs. And all of us know who've done test automation, the cost of maintenance vastly exceeds the combined costs of execution and creation. And recently I've broken this out a little bit more to try and make this a little bit more concrete for people. There are 6 phases to testing, and you don't get any value at all from your testing process until you've finished phase 6. So the first stage is the planning stage. This is figuring out what things do I need to test, what's important for regulatory uh, compliance, what are the doomsday scenarios where if this fails, everyone's going to leave our app, what is the right coverage, things like that. That's the planning phase, sometimes overlooked, but very important. Then the authoring phase, this is where you're actually writing the test cases, like implementing the test cases with code, actually writing the code. And there's a whole bunch of different ways to do this. Some people do this much better than others. This pretty much requires creating your own framework and doing a bunch of additional things as part of the authoring. A lot of people don't do this super well, and so there's a lot of focus on authoring and trying to make that easier. But that's not where people end up spending the most time and having the most issues with their testing day to day. Orchestration, this is often set once and then just continue using, but it's important to realize that as you add a new feature, you should be tagging it with which test suites should this be running with, which builds are going to execute against this, figuring out which platforms, which operating systems, which browsers, which devices need to be run, and you're putting that all in a CI/CD, usually with your configuration as code these days. Set that all up. Then is the executing phase, and this is where you're actually running it on Sauce Labs. I've had a lot of people over the years ask me to help them speed up the test execution on Sauce Labs because you're running remotely. It is not as fast as if you're running it locally. Each command you send is taking 0.2 millisecond or 0.2 seconds instead of microseconds on your local machine. And there's ways to improve that performance. There's all sorts of strategies for reducing the number of unnecessary commands that are getting sent in the background, and how to create redundancy in what you're working on without increasing the performance. The problem is I'll see a lot of people ask me this question, and I'll say, well, what is your pass rate? And I had one company like, oh yeah, it's 30%. I'm like, wait, pass rate or fail rate? Like, no, our pass rate is 30%. And I'm like, why should we focus on making your test suite, shortening it from 9 hours to 6 hours, if you're going to spend the rest of your week looking at the failures and trying to figure out what's wrong? The evaluating, the figuring out which of these failures are real and which aren't, and figuring out what to do about the failures, either fixing the test code for the false failures or reporting the real bugs or dealing with whatever that is. Users report spending, 4 or 5 times the amount of energy and time in stages 5 and 6 here than they do the rest of the things combined. And so people that are focusing on how do we make authoring easier, how do we execute faster, I think they're missing the big picture of this is the place that more people, I think maybe people just don't want to admit that what they have is not as good as what people think they have. But this is the opportunity for improving your throughput, because if you can evaluate things quickly and then resolve them, you're getting value faster. Again, you don't get any value from your tests until you finish step 6. So the generic test matrix here, you have a feature that you're testing. The test for that feature is either passing or failing. Test is passing, the system's working correctly. That's what you're looking for. You want high pass rate. You want to keep most things in green there. The problem issue is on the upper right quadrant, a type 2 error where the feature's not correct, but your test is passing anyway. Be really careful, because this is the dangerous one where you think you're fine, but you're not. I guarantee this is easier to do than most people realize. And I think a lot of the scary examples we have of software failing in the real world comes from events that have happened where they thought they had a test that would protect them from that, and it didn't catch it. And then where users spend most of their time is in the bottom, figuring out, is it a type 1 error, a false failure, or is it a real issue? So quick recap on type 2 errors. This is the stuff that's dangerous. And so I'm going to talk about it, even though it's not technically what you're spending your maintenance time on, because you can't do that. You can see things I've adopted test suites from other people that they didn't make any assertions in any of the tests. They just ran stuff and assumed if there wasn't an exception, it was probably working, which was not true, but that's what they thought made sense at the time. Oftentimes I see people in their tests making assumptions about what's going on and mocking things out. And so their tests are passing even though the system has broken since they wrote the tests, or you just wrote the wrong thing. This happens so often. If you've heard of like test-driven development where like write the test, run it, it's not passing, implement the feature, now it's green, that's great, and then worry about refactoring it later. But how do you validate your test? How do you make sure it does what you think it's doing? I'm pushing this. Make sure it's passing, and then toggle the failure condition that you're trying to test. And you may be surprised. I've run into this myself. I'll write something and I think it's going to catch the problem, but I toggle the thing that it's supposed to catch, and I didn't write the assertion correctly. And I'm like, oh, right, yes, it needs to capture this exception instead of that, whatever it is. Make sure that it can fail, and then fix it and commit it. So that's just an important aside. That's not where we spend our time. Where we spend time is we have all these failures. And really going through and making sure you can see all of the failures, you're grouping failure conditions, you're focusing on the new ones instead of ones that have been failing for months, because that's more likely something you need to deal with immediately. To figure out how to rule out obvious issues, this is where the assets on Sauce Labs are really helpful. You can see the screenshots, you can see the videos. And then you have to manually reproduce the problem, and then you're reporting it or fixing it. So all of these things, if you can find ways to do this process faster or make it so you don't have to do this at all, that's where you're going to be saving your time. 10 reasons for where you might get false failures. All sorts of different things. I'm going to call out the last one, the site design updates, because of the 10, this is one of them. The site update can be either minor or major, or it can be the feature itself change, where you have to have a different flow or a different interaction with a form element or something. And I just want to call out really quickly, there's been a big push for self-healing tests and fixing locators on the fly. And I just want to point out, of those 10 items, like the 4 sub items of that 10th one, it's only if there's a minor site update that broke a brittle locator that self-healing is going to fix. And if it's automatic, it's going to hide it from you. And it's entirely possible that it self-healed to the wrong thing, and now you're in a type 2 error where you think things are fine, but it's not, because it did it before you. So just pay attention to that. Be careful. It can happen in the real world, so be careful. You can write better code in a way that makes it easier to see what's going on. The most common failure that you get in Selenium or Appium is element not found, but most often the element not found error is not the problem. You're trying to do the next thing on the next page when the problem was the form didn't submit correctly on the previous page. So you've got an error message that's not the real problem. It's not giving you useful information. The stack traces take you to the wrong place in the code. All sorts of problems here. Finding ways to write your code so that it's more obvious when there's a problem, what that problem is, can save huge amounts of time. And I've given a number of talks on ways you can abstract out page objects and manage your test data in parallel, things like that really make a difference. Also understanding testing known states, making sure you can get false failures from trying to run too many things in parallel on one underpowered CI tool. I've had that happen. Bunch of failures because of that. Maybe the site you're testing against, you've deployed it, into a container, into an AWS server that's like way underpowered, and then you try to run 100 tests in parallel against it. That's not going to go well. And just the testing on this is network issues. Like, so many staging environments have problems that really slow down how you can test. You can end up getting a lot of failures just because your network can't handle what you're trying to do on it. And the important one for us is what you're testing on. We make sure that you have a known condition, a known start state with every single virtual session you start, or that your real device is set up exactly the way you need it to be before every single time so that you can have deterministic results. And I'm going to end on just talking about the sauce dashboard and how we're triaging tests and how we're thinking about getting results faster. In beta still for a lot of people, but this is a snapshot of what I had in my dashboard last month. Glanceable test status, you can see right off how green, how red. You've got key metrics that show up front and center here. You've got it's broken down by build that were run and shows you what your pass fail rate errors were per execution. If you're running visual tests, it shows visual down here. The failure analysis, this is what's really good. I mentioned like grouping like failures. This is really good at taking a look at all of the tests you've run, everything that's failed in those tests, and saying, hey, these 10 tests failed for what looks like the same reason. If you fix one, probably it'll fix the others, kind of help you triage that down. And then we've got flaky tests called out here, and then just an idea of what device coverage that you have, and if there's perhaps one platform that's giving you a lot of problems. Just essentially a way to look at an overview and see what things you need to focus on first so that you can reduce the amount of time you're spending figuring out if your failures are real or not. Everyone's favorite slide, the question slide. So I think there are some questions in here. All right, so is emulators simulators only for automation? No, you can use our live testing to open up your application or a mobile browser on either emulators or simulators with the settings of your choice in the drop-down menus and pull it up, and you can test against the generic version of that device. So absolutely, you can do that with live testing, and a lot of our users do that. Does Sauce Labs have a solution that supports bypassing additional Windows security pop-ups? So yeah, so it depends on what the pop-up is and what the security is. The browser itself, the traditional Selenium WebDriver Classic specification is focused on the pop-ups that the browser specifically controls. If it is something that the operating system controls, it's outside of what the driver can influence on the browser. So this is classically the file download. You try and download a file, Selenium's not going to be able to interact with that dialog. And so what we do in Selenium to get around that is you send keys to the ID of the input type of a form field, and that kind of will do it for you without having to go through that dialog box, because Selenium can't deal with that dialog box. We are moving to implement WebDriver BiDi specification. If anyone's got any questions about what Selenium's working on, I am one of the project leads. Tell you more than you want to know about any and all of that. But we are working on a WebDriver BiDi specification that is going to give you a little bit more control over some of these things through a socket implementation that wasn't directly available just going through the driver itself. A high average pass rate could also be an indication that the tests are not thorough enough. Absolutely. Coverage matters. That is one of the ways that we improve. One of the recommendations that a lot of us have is delete tests. Delete tests that probably aren't giving you enough information. If you have a 50% failure rate, you are not getting a strong signal. If you only run the tests that you know are giving you useful information, even if that means not running half your tests, that could be more beneficial than running your whole test suite, because you're not actually getting value at all when you're running with that many failures. So absolutely, it's a balance. Absolutely, you have to figure out what are the top priorities, what things really need to be done, and what you can do to make sure that you're testing enough without getting a high failure rate. And this is where can we change these to can we convert these to API tests? Can these be service layer tests? Hey, this UI test is testing functionality that we don't own. I was working with a client, their manager had me wanted me to help them do continuous delivery. He's like, my team can't seem to figure this out. Can you, help them walk through it? I'm like, sure. And I sit down, I'm talking with them. They end up being a really bright group of people, and I was like, okay, go ahead and run this test, and let's walk through what's going on. And they're like, oh, we can't run this test right now. The market's closed in Japan. And I'm like, that is completely out of your control. Why does your test rely on that? And so if you're getting failures because you can't run tests at certain because you're relying on information external to what you have control over, or even like I see people testing their PDF generation software. I'm like, did you write the software for the PDF generation, or are you relying on third party? It's like, oh, third party. I'm like, then test the input in your code. Don't try and do it in the browser, because that's not what you control. You control the input. The output is generated by software that's outside of your control. So test it where it makes the most sense, where you're getting the most value, instead of trying to do everything. I would much rather you run fewer tests very frequently than a whole bunch of tests nightly where you get so many failures it takes you a week to evaluate things. So absolutely, Michael, there's a huge, very context dependent. There's a huge range of what you need to do to figure out if you're testing enough, testing in the right spot, making sure that the test results you get tell you what you need in order to triage it quickly, and then just finding smart ways in the code and your abstractions in your approach to minimize the failures in the first place. Are there any plans to support native OS dialogues? Will there be a BiDi-based MCP server? I believe the answer to that is yes and yes. We are still working on the BiDi implementation. There are a lot of things that the browser vendors themselves are still actively working on implementing to get these. So it really depends on what the native OS dialog is. And it depends on if you can interact with that through the browser itself. So I would need to know specifics. I'm not up to date on exactly what all is being implemented for that, or what has been specified. But I do know that there will be a lot more options. Things like basic authentication has stopped being supported in a lot of places. You can absolutely do that with BiDi today. So common things like that. What's another common limitation? You can only set and retrieve cookies in Selenium currently if you are navigated to the domain you're interacting with the cookies. With BiDi, you can set a cookie on a domain you're not on, which is great for testing. You get an authentication token with a REST client, add a cookie with that authentication token. You can add it to a domain you're not on. Oftentimes, your login will redirect you to a domain that the cookie doesn't need to be on as part of the process. So it's a lot of interesting things can come from that. So, can I answer both your questions? Is there any follow up or anything I can provide on that? I guess I'm not quite. I'm like, yes, ask me anything about BiDi, and I'm like, oh, I'm not sure about that. So we're working on it. Things are moving forward more slowly than I would like, but we're definitely making progress, and hopefully we'll have some more to announce soon. A lot of things are happening behind the scenes that should make a difference, but we'll let you know when we know for sure. Yeah, feel free to reach out to us. Again, the best way for a lot of these common things that you expect a lot of users to be running into is our support team, because they've got so much knowledge about interacting with things on a day-to-day basis, and new bugs that have come up in specific versions and things like that. They manage most of that themselves, and then reach out to me if it's like, hey, their code is having some problem here, and then I jump in and get involved. But yeah, thanks everyone for your time and participation here. Thanks for the questions. Let me know. I guess I didn't answer specifically I just see the BiDi based MCP server. We are working on a Selenium MCP server. At the conference, Angie Jones was showing an MCP server, and then Diego has pulled that down and is working on it. There's a lot of interesting things we could do there. The unfortunate thing with the Selenium project is it is all volunteers. Uh, some of us have the opportunity to work on Selenium as part of our responsibilities of the companies we work at, but it's still somewhat part-time and somewhat up to us what we are able to do at any given time. So we're not a Microsoft team with a full with the backing of a large product team and developer experience engineers and such. All right. If there are no more questions, then thank you everyone for your time. We'll go ahead and end it there. Really appreciate everyone being here, and I hope to see you at our next webinar.